Okay, for question 3 we need to complete the table, and hopefully you can see that this is very straightforward. We just do that minus that, which gives us 5.1. Okay, next question, we need to plot the graph for 5 marks. So on the x-axis we're going to need the number of elastic bands. The reason that goes on the x-axis is because that's the independent variable. That was the thing that was changed in the experiment, and of course that doesn't have any units. So on the y-axis we've got the dependent variable, which is the dependence in length, the difference in length, and the units are in centimeters. So we need to come up with a suitable scale, and that should always fill up as much of the grid as possible. So they've been nice to us. If you look at these big squares here, okay, there's 6 of those going across the bottom. Okay, and we need up to 6. Okay, because that was the maximum number of elastic bands in the question. On the y-axis, again we're looking for a sensible scale that uses as much of the grid as possible, certainly more than half the grid, but doesn't give us any nasty calculations to do. The maximum value of difference in length is 5.1. So again, if you just take the big squares, okay, so our maximum data point is kind of going to be this high up the graph, which is more than halfway up the graph, and that's absolutely fine to get that mark. If you try and fill all of the grid, then you're going to end up with some really crazy scale, and it's going to make plotting the points much harder. So as long as you've filled more than half the graph paper there, more than happy with that. Next thing to do is to plot the points. These need to be accurate to within plus or minus one of those small squares. Okay, so as long as you take your time and do that carefully, because we've picked ourselves a nice easy scale to work on, that's really not very difficult. After you've plotted the points, you need the line of best fit. Okay, this is clearly a straight line. If it's going to be a curve, then you never see kind of wiggly curves like this. It's going to be a curve all in one direction, and it'll be quite obvious that all the points will fit on the curve, and it'll only curve in one direction. So from the graph that we've got, a straight line is the line of best fit that we need. Apologies that I haven't done this with the ruler. Obviously you need to do it with a ruler in the exam. There's a couple of points to notice though. It doesn't have to go through 0, 0. It's okay if it doesn't. It doesn't have to go through or touch all of the points. Okay, and there's a balance between points that are above the line. Okay, here you can see that there's 2 points above the line. Okay, and points that are below the line. Okay, there's 3 points below the line. Okay, and it goes very close to that one. Maybe it wouldn't if I did it with a ruler, but that's enough to get you 5 marks. So then we need to describe the line of best fit. As I've already said, it doesn't quite pass through the origin. It's a straight line, or you could say that it's got a constant gradient. It's got a positive gradient, so it's sloping upwards, and what that means is that as the number of elastic bands increases, so does the difference in the length. If you'd forced your line to go through 0, 0, then you could have said that it was directly proportional, and you'd have got a mark there for an error carried forward. Okay, but actually, if you'd plotted the line of best fit correctly, it doesn't go through the origin. Okay, so to estimate the length of this, we need to continue the lines downwards. Oops, it's not very clear, is it? There we go. Okay, then hopefully you can see from this that it's 22.3 centimeters minus 19.1 centimeters, which is going to give us 3.2 centimeters. Okay, and it's a 2-mark question, so really they want to see some evidence of you working it out as well as getting the right answer. You're allowed a tolerance of plus or minus 0.1 centimeters, So if you'd answered anything in the range 3.1 to 3.3 centimeters, then that would have been okay. Okay, improvements to the measuring technique. I think the main one is that you could see that when I was drawing these lines from here to here, okay, because the paper clip was quite a long way from the ruler, that made that quite difficult to judge that. So the most obvious one is move the paper clip a lot closer to the ruler. There's quite a few different ways that you could get the second mark. You can see that the paper clip's starting to open up here, okay, which might affect the length measurements, so using a stiffer paper clip might help. The other thing that was tricky was to judge was because these rubber bands are in place around here, it was quite difficult to judge where exactly the end of the paper clip was, so you could remove the rubber bands to measure the paper clip.